Now, another thing we want to look at is type safety and inference. Now, what type safety refers to is regardless of whether we explicitly set the type of a variable or data or Swift infers the type. Once a type is set, we cannot place another type in that type. So this is what I'm trying to explain. So let's look at uh, an inventory log, for instance. Say we have letter item name, item name, and then maybe we want to call this executive chair. So this is Swift is going to infer this as string because of these quotes. Okay. We could have another one. Let item price equals maybe we call that 129.99. So Swift is going to infer this. Floating points in Swift are automatically inferred as a double, and double uses 64 bits floating point, 64 bits of a binary fraction, if I'm not mistaken, to store this. So I think a floating point, if we explicitly set this to be float, that's going to be 32 bits. So this is double, for instance. Uh, we can have another one. Let stock count. Maybe we want to set that to be 25, and then we can do let is available. Is available. Available. Let's set that to true. Okay. Now all of these have types, although we didn't explicitly set them, but there's a way we can check their type in Swift. For instance, we can do print, and then we can do type, and then in here we can do off. Then each and every one we can do. For instance, we can do item name. I'm going to copy this again. Copy, and I'm going to paste this, and then this time I'm going to use item price, and then paste. I'm going to call is available here. Is available. Okay, so this is going to get us the type that Swift has inferred here. So let me just clear this and run. So for item name, that's string, this is double, and this is boolean, like so. So that's how we can get the type that Swift had inferred. Now, another thing we might want to do here is, so we said this is double. Okay. What if we had, let me show you an instance. What if we have, we could have a edge case situation. For instance, we can do let small decimal equals 3.14. Now remember we said Swift infers this as double, and double is 64 bits binary fraction, which is bigger. So we can explicitly set this to be float. Float uses 32 bits, which means it doesn't consume as much memory as double would have. So this is not memory management. The same way we could do something like let small character, and then if we do this to be, let's just say J. Now this is just a single character. If we leave it like this, Swift is going to infer as string. So we can just, which is going to take more memory anyway. And it's just one character here. So we can save ourselves memory by doing character. Aha. So this is going to work. So when we're trying to save, when we're going to process data that do not, the data is quite small, we might want to go with this approach. So that's another thing I want us to call our mind to. Now, look at another situation. If we have, if we have wallet balance, So this is, I don't know, maybe this is 120.67. And then let's say, let premium, let premium cost, let's call that, I don't know, 20.86, like so. Now, this is inferred as double, and this is just a string. And don't think because, okay, because it's string and it has, what is it called? Figure inside, or number, a decimal number inside, then we cannot do something like, we cannot just, I can do, for instance, I can do wallet balance plus equals premium cost. This is not going to work because this is string. As far as Swift is concerned, it doesn't know whether what we have here amount to some kind of decimal value or anything. So I can't do this. This is not going to work in Swift. And I have no desire to show you that it's not going to work anyway, but I'm just going to tell you that it doesn't work like that. So just as we can't do, just as it is right there, I can't do, for instance, even though this is mutable, I can't do wallet balance. I can do wallet balance plus equals 15 or 16. For instance, if I say let addition equals wallet balance, if I now say print addition, this is not going to work as well because, okay, let me just run it so you see. Now, see, this is not going to work. That's because this is double. Now I'm trying to add integer to it. Like we said, the whole point of type safety is to ensure type integrity so that we don't add another type into another type. So this is double. We can't place another type into that type. Swift won't allow us to do that. So that's one thing I would want us to call our mind to. What else can we do? Let's look at optionals. When we do optional, we can unwrap a value. So let's look at optional, for instance. I'm going to like delete this. For instance, let's have var optional username, and then string, and then let's call that Swift learner. Okay. Now, when we do something like this, we're telling Swift that this could be a string or it could be nil. That's the whole point of this optional character here. We're telling Swift that optional username can be a string or it can be nil. Nil means it's like null in JavaScript. Okay, so we can't just make use of this. What I'm trying to say, I can't just say print optional username. I don't think this will work. So if I say run, see, it's throwing an error. It says print optional username warning expression implicitly coerced from string to any. Provide a default value to avoid this warning. So this is not going to work, even though we've assigned a value here, but then this variable is optional. So what we have to do is we have to unwrap it by doing what is known as optional binding. So this is going to offer us a type safe solution. So the way we do this is to do if, this is how we forcefully unwrap this. We can do if let username is equals to optional username, like this. So if this has a value, then we want to say print username is username, like so. And then if it's nil, because Swift does not know, because we made it optional. For as far as Swift is concerned, this could be nil. So the way we use type safety integrity is to unwrap this. See, like this error is saying that, okay, it says warning expression implicitly coerced from string to any. Note, provide a default value to avoid this warning. See, first unwrap the value to avoid this warning. Explicitly cast to any with blah blah blah. Okay, so we have to first unwrap this because it's an optional what is it called? It's an optional variable. So here we're saying, okay, if let username, so we reassign it to another variable. So if let username is this, okay, which means this optional variable has a value. Then if it has a value, we want to print that value. Otherwise, we can do else print our value is nil, like so. So I'm going to like clear this out, and then I'm going to run this. Okay, so it says username is Swift learner. So Swift found that this has a value, even though the variable is optional. Now, if we didn't set any value here, for instance, let's just do this. So Swift is optional, so which means it can hold a value or it can be nil. So in this case, we didn't assign any value, so Swift sees this as nil. And then we have first unwrap it here. We first unwrap it here. So this is not going to break. Once Swift check this, if let username because optional username, okay, so it doesn't have a value yet. So Swift is going to go to this else block and then print our value is nil. Okay, so I'm going to clear this out again, and then I'm going to run this. See, say our value is nil, which is essentially saying, okay, this is null. But in Swift, we use nil. So I'm just bringing null for those of you who are familiar with null. So perhaps you might think of this as a way to handle null safety, like with in other programming language when we're doing null safety. So this is like Swift version of null safety. So guys, that's all for type safety and type inference. So the takeaway here is the idea of type safety is to give type integrity to our data such that when a type has been assigned explicitly or Swift inferred it, we cannot put another type into that type. So guys, that's all for this video. I'll see you soon.